Okay, this is lesson 1.4, collecting sample data. So the basics for collecting sample data, the first thing is an observational study. Now, observational studies are when you kind of sit back and just watch things in their natural element and you don't really change anything and you write down data based off of your observations. It can also be doing things like researching past events. Those would be observational. There's a lot of people that don't like observational studies. They don't think they're very effective, but there's a lot of quality. They're also called qualitative studies because you see things in their raw environment. You don't change anything. You don't force them to act a certain way. You just see them as they are and you write down the data according to what you see. There's also another form, which is the common one that we all know, experiments. Experiments is when you put a treatment on your study participants. Now, a treatment meaning you manipulate something to where it forces them to make a decision or act in a certain, or forces them to make a decision in how they're going to act or what they're going to do in that situation. That treatment is what makes it an experiment, and it's considered much more valuable because it takes out all the underlying things that you don't know about. You know what's causing the behavior because you put a treatment there to cause the behavior. And so experiments are considered much more valuable. However, if you ask me, observational studies are very valuable, and they kind of get the shaft there, okay? Those that participate in an experiment are called experimental units, okay? Or the subjects are what they are. Now, there's what we call a lurking variable with observational studies. A lurking variable means you don't know what's causing the behavior sometimes. For example, you go to the store and you see someone like chewing everyone out, being rude, and you just think that's a rude person. They're yelling at their kids, they're yelling at the employees, and you're just like, that person is rude, right? And so that's your observation. However, you don't know what's causing that behavior. Maybe back home, they just found out their husband's cheating on them. Maybe they just lost their job. Maybe their kid just failed their classes, and who knows what else could be going wrong in their life, and they're just acting out because everything's going wrong in their life. You don't know what's causing them to behave that way, so that's called the lurking variable, and that's one of the problems with observational studies, is you can't pinpoint the exact reason for each behavior. Now, I'd like you to pause this video and watch the videos that I post for Studio C. Okay, so there are going to be links that I posted or videos. Look for those and watch them now, please. Now, that's just a fun way for you to see a study, right? Just kind of as a joke or an experiment. Now, there's different ways to collect samplings, okay, or to get samples. There's different methods. The first one is a systematic sampling, or a systematic method. This is when you follow some kind of rule to get your samples. So, for example, you're standing at a fair and you're going to study every 5th person to come through the gate. So that's your rule. Every 5th person becomes part of your study. It's systematic. Another sampling method is convenience sampling. Convenience meaning it's easy and accessible. For example, I'm a teacher. I have 30 students in my classroom. I want to get an easy sample or a convenient sample, so I just study the 30 students that are right there stuck in my class anyway, right? That's convenient. Or you go and use your neighbors in your study, or people at work, whatever it might be. That's convenience, and so it's called a convenient sample. I'll tell you, convenient samples are rarely very effective because they don't really get the full view of the entire population. People that work together, people that are doing things together, going to parties, whatever it might be, those people are going to tend to think alike. And so your study will be somewhat flawed. There's stratified sampling. This is when you break people up into groups based off of some defining characteristics. So maybe their age, maybe hair color, whatever it might be. And then you take people from each of those groups and put them into your study. There's clustering. Sorry, the last one, the people that are put into the subgroups that you put people into, they're called strata, by the way. Okay, now clusters or clustering. Clustering is when you separate, it's kind of like stratified, But what it is you're breaking people up into sections. These sections are things like maybe neighborhoods. You have this neighborhood here, that neighborhood there. You take people from each neighborhood and you do your study, okay? So that would be a cluster, a city block, something like that. The last one is random sampling. I saved it last because it's the most important part of doing a study. You can put randomization into each one of the other types as well, and that will help improve those studies. But random sampling is when every subject within the population has the same opportunity of being chosen. Meaning, you don't have any bias in who you're selecting. You're not looking for just blonde people. You're not looking for tall, short, skinny, whatever it might be. Any person who fits within the parameter of the population can be chosen equally. So that's randomization. McDonald's has an example of doing this. When they want to survey their customers, if they sent an employee out and said, hey, do this survey with guests that come in, there's lots of things that could mess up the results. For example, they could ask someone who's on their way to the bathroom and wasn't even there to buy anything. That's not a customer, so therefore that data is not valid. Or if most employees at McDonald's are young teenagers, they might feel more comfortable talking to other teenagers, or they might even feel comfortable talking to seniors. But then everyone in between they don't talk to because they're not comfortable talking to them. And so that also affects the data and makes it not so accurate. And so what McDonald's did was they had a rule that anytime someone came in and used one of their coupons or their discount things, the very next person in line is the one that you would survey or the one that you would question. Now what that does is this, it makes it completely random. First off, you're not doing everyone who uses discounts because those people tend to think alike, they want to save money or whatever it might be. You're using the person next in line, that could be anybody, okay? And so that makes it random. There's lots of ways to do randomization. If you want to do, let's say you took the senior class. In college you have senior classes, right? But anyway, you could assign everyone in senior class a number, and then in your calculator there's a rand function. You select that, close the parenthesis, you won't put any numbers in there, and then you just hit enter and it will pop up different numbers randomly. And what that does is, now anyone who correlates with those numbers, those are the ones that you're going to put into your study. So if you want 50 people in your study, hit the button 50 times, look at the numbers that came up, look at who they're assigned to, and those are the people you study. Completely random. You didn't have any way of affecting who got chosen and who didn't, okay? All right. There's a multi-stage sampling that can occur in which you use different methods throughout the study. So at one point you might be doing a convenience sample, another point you'll be doing a stratified sample or whatever, just whatever it takes to get through the sampling method, okay? Now let's talk a little bit more about observational studies, okay? There are different types of ways of doing observational studies. The first one is retrospective. This is looking at things of the past. Now normally the way you do retrospective stuff is you study old newspapers, or you interview someone who was there, a World War II veteran. You talk to them about their experience, and that's part of your retrospective data collecting, okay? You examine records and so forth. Another type of way of doing observational is cross-sectional. This is data that is observed and measured at a single point in time, and it's not continuous. So purely right now, at this moment, this is what you're looking at. That's cross-sectional, okay? Next is perspective or longitudinal studies. This is data that's collected for the future. So for example, you might be taking cell phones. You're going to observe groups that use cell phones and groups that don't use cell phones. And you study them at one point in time, and then in the future you get them together and you study them again, and then in the future again, or however you might do it. That is perspective studies, okay? So it's a continuous study. Now in designing your experiment, there's different ways of doing things that you need to look at. First off, you need to make sure it's randomized, okay? Randomization. This is random selection assigned subjects to different groups. So use some kind of random selection to assign people to their groups. Another important factor when designing your study is it has to be able to be replicated, okay? Someone else has to be able to do that study. There are studies that have been done that no one else can replicate, and therefore it can't be verified. Your study needs to be able to be verified, okay? They need to be able to repeat it verbatim. Next is what we call blinding. So when you're doing a study, things you might consider is the subjects don't know that they're being studied or what the treatment is, okay? Really, they don't even know what the treatment is. And the treatment is also called the placebo. Now guys, there's a problem that sometimes happens with this when people don't know that they're the ones receiving the treatment or not. We have what's called the placebo effect, where people who didn't receive the treatment said that they had signs of improvement and the treatment wasn't even given to them. Now whether that's a mental thing or what it might be, that often happens, and so they'll use what's called blinding to help reduce that. Okay, actually blinding is what helps reduce that. Sorry, the subjects don't know that they're receiving the treatment. The placebo effect is when an untreated group reports improvements in symptoms. Okay. Next is double blinding. That's when both the subject and the investigator, meaning the person performing the study, don't know who's getting the treatment. That's another way of preventing some of that placebo effect, okay? So, of course, there has to be someone that knows, but not the people that are out there interacting with the participants. Now, confounding is something that can often occur in your studies. This is when you're unable to identify or distinguish the effects of different factors. Now, you don't know what's causing the change or whether or not the thing that your treatment is actually doing anything. And so if you can't identify that, if you can't specifically say this is the reason, then it's called confounding, and you want to make sure you avoid that when you're putting together a study. You want to make sure you think about all the stuff that could confuse it so that you eliminate those things and you plan for them so that you can identify the exact thing within your study that is causing the effect. Now, in designing experiments, there are complete randomized experiments where everything is assigned randomly. There's random block design. This is, now a block, guys, is a group of subjects that are similar, okay? So they have similar characteristics, similar whatever it might be, behaviors or whatever, okay? So the way you do these block designs is you form a block by subjects with similar characteristics, and then you randomly assign them the treatment. Notice that randomization still comes into this in order for it to be effective, okay? So even though you're putting people together with similar characteristics, you're still randomly selecting who becomes part of the study. There's also called matched pair design. This is when you compare two treatment groups using subjects matching in the pairs of similarities. For example, twins. Crest did a study where one twin used Crest and another twin used a different toothpaste, and they checked their teeth out after a certain time and point, and that right there is matching pair. All right. There's rigorously controlled design. That matches a subject in each group with similar characteristics. For example, if you have a smoker in this group, then you put a smoker in that group, right? That way you have someone from each group that is matching with similar characteristics in each group. Okay? And that's rigorously controlled groups. Now, when you're doing your studies, you need to watch out for sampling errors. And what that is the results do not really demonstrate the overall population, okay? So it doesn't really show what the population thinks or acts or whatever. I'm just trying to think at the top of my head an easy example of this. Let's say you're at Disneyland and you want to know what everyone's favorite character is, and it turns out that everyone's favorite character is Donald Duck and not Mickey Mouse. Well, the sampling error might be maybe you didn't choose people randomly, or maybe you're standing over by Donald Duck and the people waiting in line for Donald Duck are the ones that you're talking to. And that would be a sampling error, okay? A non-sampling error is a human error. This is when the person doing the study makes some kind of mistake. For example, they enter the data wrong. They have surveys with biased questions on them, or biased wording. There's false data by respondents. I work with students, they give false data for surveys all the time, trust me. They just mark whatever and say whatever. There's biased conclusions. So based off of your past history, you draw conclusions on the study based off what you want it to prove. And so that's bias. Or simply maybe you did your math wrong. You know, all those would be non-sampling errors. Finally, a non-random sampling error is just you didn't use a method to randomly select people. And so if you don't have randomness within a study, your study is not completely accurate. And it can't really represent the population completely. All right, that's lesson 1.4.